Welcome to week number 3 for the live interactive session on water supply demand estimation for the course Water Society and Sustainability under the leadership of Dr. Jenia Mukherjee, Assistant Professor, Department of Humanities and Social Sciences, IIT Kharagpur. I am Amit Srivastav, the TA, and let's continue our long series of discussion since week 1 on this topic. So, before we proceed in the details of week 3, let's revise what we studied during week 2. In the week 2, our objective was to determine the seasonal water budget, and we arrived at land use wise water budget for each season for the village. Here in this slide you can see the agricultural land use seasonal water budget, wherein we can see here that how surface runoff is one of the very dominating process, mostly during monsoon and post-monsoon seasons. Also, we realized from this discussion on agricultural land use that how more than 70% of the rainfall is unutilized and part of surface runoff. And because of this, it resulted in low water storage during winter and summer, which is evident from the graph. And we can see here that how the water which is received during monsoon, it's steadily declining from monsoon to post-monsoon to winter and summer in the following years. And that's why we can find out why the cropping seasons is limited to one, that is mostly during monsoon season or kharif season, while rabi cropping is somewhat challenging given limited water availability during the rabi season or winter season. Likewise, we developed seasonal water budget for forest land use as well, and we found there that the unutilized water was even greater as compared to agricultural land use. And that's why we found that even forest cannot be an reliable alternative irrigation source, given the fact that the water availability is very less within the forest land use, and most of the water is becoming the part of surface runoff and unable to be get captured. Moving ahead, we also developed the seasonal water budget for built-up land use, and we found that it is having the highest surface runoff as compared to any land use form available in the village. And we found that how the scope of harvesting surface runoff in village is very limited, and that can be one of the major reasons as why the water scarcity is prevailing in the village, not with regards to agricultural water crisis but with regards to domestic water crisis as well. And finally, the fourth land use, which was the lake, the only source of water in the village. It is a surface depression which was storing the water, and we found that here the surface storage process dominated, which is observed from this graph, and it was able to store more than 90% of the rainfall. That is the success of this lake. However, the fact is the water is lost very steadily from monsoon to post-monsoon and thereafter in winter and summer. And we can see here that how storage is almost very less or not of having that potential to support agriculture or other water demand winter and summer. But yeah, when I say water demand, we really don't know how much is the water demand, but we are presuming based on week 2 estimations that since the water availability is steadily declining from monsoon to the following summer, hence because of the less water availability, many other avenues of demand may not be fulfilled, but that requires to be checked, and that is what is the aim of week number 3. Let's revise the problem statement with regards to developing our experience for the concerned village. You are a technocrat come policymaker investigating a village since last couple of weeks, located in the semi-arid region of East Maharashtra. You were told that the village is witnessing water scarcity problems during the non-monsoonal seasons. You identified utilizing the data that excess surface runoff is an actual cause behind water scarcity. Yes, in the week 1 this was one of our assumption. In week 2 we confirmed that yes, it is the excess surface runoff which is the dominating process, at least from agriculture land use, forest land use and built up land use. The reason behind excess surface runoff was ascertained for high temporal disparity in monsoonal rain apart from the undulating topography. Yes, so we have seen in the previous week that the monsoon was not very uniform across all the season. We found that monsoon was one of the very dominating process in the monsoonal season, which is June, July, August, September. Also, we saw that how the topography was undulating given the fact that the elevation was higher at the upstream while the elevation was declining right from upstream to downstream. So with this, let us revise our objective for week 3 based on the learnings from week 1 and week 2. That is to estimate seasonal water budget considering water supply and demand aspects of a typical Indian village based on the learnings from week 1, 2 and 3 lectures and revised recommendation for management. Right. So we have been giving recommendations right from week 1, but now with the knowledge of water supply and demand, we will try to understand the correlation between how much is the water available, how much water is being supplied and how much is actually the demand, and whether the supply is able to meet the demand and how much is the water availability or unavailability, that we are going to look into while considering this objective for week 3. So the conditions, it remains the same based on the learnings from your weekly lecture on water, society and sustainability. Climate change as a planetary boundary framework will be our consideration. Water will be considered as a resource to be managed, controlled and hence quantified. We will be talking in the context of socio-hydrology, political ecology and hydrosociology of water. And we have been witnessing how transdisciplinary approach has been used in our in the series of the discussions that we have been doing. And we are not limiting ourselves to just one discipline such as water resource engineering or civil engineering, etc. We are accounting many disciplines together while framing our recommendations and understanding the data. Definitely, by following all these conditions, we are advancing the science of hydrology for the benefit of society. Here, our society is the village, where we are investigating the water availability. And at the same time, we are looking forward for designing some recommendations. And although we have been realizing that all the time through the discussions, we are actually using integrated water resource management frameworks while designing our recommendations. So keeping all these conditions intact, let's move ahead. This is our village which we were discussing, the forest land use at the most upstream, and the elevation is decreasing from forested land use to lake. We have built up, we have agricultural land, and this is the lake as a only surface water storage structure. Now, since we have already studied in detail how to do the water budgeting, given the fact how to use the hydrological equation, which we discussed in the last couple of lectures. In this week 3, our focus is more towards water demand. Now we are interested to find out how much is actually the demand coming up from the village. Through the investigation, we found that these are the 7 avenues from where the water is being demanded, which includes domestic water demand, livestock water demand, and the demand from institutions such as Jila Parishad School, Anganwadi, Primary Health Care Center. This is a hospital, a local hospital for the village, Panchayat office. So these are some of the institutions where water demand is required. And we have agriculture as well, which is a very primary source of water demand. So we will be looking into the details of how the demand of all these 7 avenues are and how to quantify them and how to find out the total water demand in each season. So let us start with the non-agricultural water demand. When I say non-agriculture, that means except agriculture, we will be considering all other six as the water demand sources. So we will be considering domestic, livestock, ZP school, Anganwadi, PHC and Panchayat office as the non-agricultural water demand sources. So you conducted household survey and field investigation using both focused group discussions and interviews and obtained the following data. So this is based on what you investigated for the in the village. So for the source domestic, firstly we found that the total population in the village is 1250 and the water demand in the unit of liter per capita per day. So this is as per the requirements. We find that it is 40 liters per capita per day in each season. So we have four seasons like winter comprising January and February, and the number of days will be 58, you can calculate. Then we have summer having the months May, June, July. Sorry, it is March, April and May having 92 days, followed by monsoon having June, July, August and September having 122 days, and post monsoon season having October, November, December as 3 months and having 92 days. So across these four seasons, we found that the water demand for domestic will remain the same because it's the domestic water demand which is mostly, when I say domestic water demand, I am more specific to drinking water demand basically. So when I say domestic, it is more into drinking water requirements. So this is the 40 liter per capita per day. That means 40 liter of water is being consumed in one day by one person in the village. So for each season we have taken 40 liters per capita per day, LPCD. Likewise for livestock, there are 575 animals, maybe cows, buffaloes. So sum together their population is 575 and their water requirement is 60 liters per capita per day. Likewise for school, the population of the students in the school is 100, and although we understand that there can be summer holidays or winter holidays, but since our summer is stretched from March, April till May, so we find that some days of summer is still the school days, likewise some days of winter is again the school days. So that's why we are taking our maximum assumption. So 30 liters per capita per day is what is the capacity that we found from the field investigation, which should be maintained in each season for the school having the population of 100. Likewise in Anganwadi the population was 50. When we say Anganwadi, it is actually the child healthcare center having the age less than 5 years, and therein we found that the 25 liters per capita per day is the water requirement in each of the season. Likewise for Panchayat office, the capacity of Panchayat office to accommodate the population is 50, and therein, since it is an institution, we are keeping 25 liters per capita per day as the water demand in each season. For the hospital, which is the primary health care center in the village, it is 35 liters per capita per day and having the capacity of 50. So when we say 50, it is having all the patients in the sense like bed patients as well as the patients who will be coming during OPDs, open patient day. So I hope you understood the various kinds of demand in each of the seasons, and you see here that number of days in each of the season is different. So accordingly our water demand in each season will be calculated. Here is the sample calculation for non-agricultural water demand for domestic. So we know that the population of the village is 1250 and the per capita water demand is 40 liters. So let's estimate for each of the season. We have winter where 59 days are there. So to find out the total domestic water demand in liters, what we are supposed to do is to multiply the number of days of the season with their water demand, which is 40, and the total population. This will yield 29 lakh 50,000 liters of water which is required in winter season. We can convert it into meter cube by dividing this amount, the liters, by 1000, which will give us 2950 meter cube. And since we have been estimating all the water aspects in the units of 1000 cubic meter TCM, so we will divide it further by 1000 to get it in the unit of 1000 cubic meter, which is 2.95. So in the winter the water demand is 2.95. Likewise for summer the demand is 4.6. For monsoon it is 6.1, and again in post monsoon it is 4.6 thousand cubic meter. So these are the seasonal water demand for domestic purposes. So this was the domestic purpose, this was the population 1250, and this was the water demand, that is 40 liters per capita per day in each of the season. This data we used to find out seasonal water demand. Likewise, I expect that the enrolled candidates should find out the water demand for livestock, ZP school, Anganwadi, Panchayat office, etc. by themselves, such that you should get an hands-on experience of identifying the water demand of each of these aspects or sources. So I have done one for you. You can take the reference of domestic water demand and can apply for the remaining sources. And here is the summary. So once you are done with finding the water demand, you can verify, you can cross-check your calculation with this graph. Here we are showing all the water demand in each season for each of the sources, and let's analyze now. So here we estimated domestic as 2.9, 4.6, 6.1, 4.6, which is written here. This is how we estimated here: 2.95, 4.6, 6.1, 4.6. So this is what here it is written for each of the season: winter, summer, monsoon and post monsoon for domestic purpose. Likewise for livestock, we found in the units of 1000 cubic meters. Here it is written TCM, it's in the units of 1000 cubic meters. We found that the livestock water demand is slightly less than the population water demand or domestic water demand, which is 2, 3.17, 4.21 and 3.17. Likewise, we found for ZP school, Anganwadi, Panchayat office and primary healthcare center, and we have plotted them here. So from this plot we can see, we can have a judgment that from winter to monsoon the water demand is increasing, and we all are aware of this fact that the water availability in the village was falling from monsoon to falling summer, and the demand is increasing. So this is, both are following the opposite trend. Secondly, we can see here that the highest water demand is coming from the domestic purposes, right? So domestic purposes is having the highest demand. Remember, when I say that the domestic purpose is having the highest demand, it is just the drinking water demand. I haven't taken into account the other demands within the domestic uses, such as utensil washing, cloth washing, bathing, etc. So that has not taken into account. Still, domestic water demand is leading in the village, followed by livestock water demand. So it is the indication that livestock is one of the very core occupation in the village following agriculture. Likewise, for school we can see it is the third highest across each season, and likewise for Anganwadi, Panchayat office and primary healthcare center, they are also having some demand. So if we sum total all the demand, because our interest is to satisfy all this water demand, but we want to see whether such amount of water is available in each season or not. So in winter, sum total of all this demand is 5.32. In summer it is 8.44. In monsoon it is 11.19 thousand cubic meters, and in post monsoon is again 8.44 TCM. So now we need to remember these values. These are the total water demand in each of the season from these many sources, and the demand that we have estimated here is the non-agricultural water demand, right? Now let's move ahead. You conducted a household survey and field investigation using both focus group discussions and interviews, and obtained the following data for agricultural water demand, right? So you found that in winter farmers are growing onion. In summer you found that since water is not available, so no cropping is happening in summer. That is March, April and May. In monsoon, due to the ample water availability, farmers were preferring growing paddy, which is a water-intensive crop. And in the post-monsoon season, again, the choice of farmers is the onion in the village. Here are the details of this cropping. Onion usually require 100 days of cultivation or irrigation, and rice requires 120 days. So it's seasonal crops. And the demand is also mentioned here. That is 400 mm of water is required across the season for growing onion. Likewise, it is 700 mm per season is the water demand for paddy. This data has been obtained from Food and Agricultural Organization (FAO). Now we all are aware that in the village the crop area was 35 hectare, but these farmers were not culturing or cultivating on the entire crop area. It was just 15, 30 and 25. But when we will be estimating the water demand for agricultural purpose, we will be accounting this entire 35 hectares such that we can come up with the comprehensive water demand for agriculture. Now let's see a sample calculation of, or I say it is not at all a sample calculation, it is a total calculation, because we were having 4 seasons and for all these seasons we have estimated the agricultural water demand. So we all know that the agricultural area was 35 hectare, which is 350,000 meters square. Now in winter we are aware that the crop was onion, so which was and the water demand was 400 mm per season. So our season here is winter. 0.4 meter of water is required, and this 0.4 meter of water is required across 350,000 meter square area. So let's multiply them such that we can get the volume of water in meter cube. And since, as we discussed, that we wanted everything in 1000 cubic meter, so we will divide the final term by 1000 and we got 140,000 cubic meter of water required for growing onion in winter. So it is a huge amount as compared to non-agricultural water demand, because nowhere it was touching the mark of 100. Here the winter water demand is 140,000 cubic meters. But in summer, since no cropping was happening, so the total water availability or demand is 0. While for paddy in the monsoon, it is almost double, which is 245 TCM. While in the post monsoon, it is again 140 TCM, because their choice is onion only, right? So I mean to say here that since the water is available in plenty during monsoon season, hence farmers were practicing growing paddy. And if they want to cultivate paddy, the maximum water they need is 245. But we are all aware that farmers were not exactly cultivating in the entire 35 hectare area, so they need little less water. But the question here is like, why they are unable to cultivate in the entire area? One thing could be that since the water is not available, there is a water scarcity issues. That's why they are not risking themselves to use their entire crop area to cultivate. That's why most of the farmers preferred growing in certain portion of their land rather than total land area. As a result of which, we found that there is a huge land area which are agricultural land, but farmers are not growing crops over there. So this data itself is giving us an hope or a scope to make water available such that each farmer can increase their potential of growing crops from the maximum portion of their agricultural land. So this is how we have obtained the agricultural water demand across each season. And here is the representation. So here I am not only showing the agricultural water demand in green, but I am also comparing this demand with the non-agricultural water demand, which is NAWD. So we had estimated these values in the previous slides, and here is the comparison. So you can see that In the monsoon, both non-agriculture and agricultural water demand is dominating and high, and it decreases to somewhat during monsoon season, while it is further decreasing in winter but increased in summer. So the non-agricultural water demand pattern can be seen here, which is maximum in monsoon, followed by post-monsoon, then summer and winter. While in the case of agriculture, since it is mostly rain dependent, hence we cannot see agricultural practices during summer season, and hence there is no demand. However, although they are not practicing agriculture or cropping during winter and post-monsoon season as well, but this is what the demand is, which is needed to be fulfilled. So one thing is certain, that we need to compare this water demand with the water storage in the village. So let's now compare the findings that we got from week 2 with the findings that we have just now obtained in this week 3 interaction. And here it is. Firstly, what I'm trying to do here is, in this graph you can see the summary of season-wise water availability in the village. When I say water availability, it is the rainfall, storage, unutilized water and runoff. So you all remembered that in week 2 we identified all these sources, all these water sources for each of the land use. Now what I have done here is, whatever the rainfall which was received on each of the land use, I have added together to get the entire village rainfall volume. Likewise, I have added the storage of each of the land use together to get the entire storage from the village. Similarly, the runoff which we estimated from each of the land use, now we have added all the surface runoff generating from the land uses, and thus whatever the runoff that we are now getting is for the entire village. So this is the summary of the season-wise water availability in the village. And if you look carefully, we see here that the monsoon is having the highest water availability in the form of rain, which is 2000 TCM, of which the storage is merely 465. So you can see here that even, half of 2000 is 1000 and half of 1000 is 500. So we see here it is not even half of the total rain volume that was received in the village. And this is the unutilized water, and we are calling it as unutilized because we cannot utilize it, in the sense that this unutilized water is mostly comprised of evaporation, evapotranspiration and groundwater infiltration. So we had discussed in the previous weeks as how these three sources of water cannot be utilized, and that's why it is categorized as unutilized water. So we do not want to look here, but our interest is this surface runoff, which is very high, and we can say it is more than 50% of the rainfall volume. If you look at post-monsoon season, again here the surface runoff is very high. It is like almost 80%. I hope you must have been using calculator here. So if you use calculator, 334 divided by 500 into 100, that will be somewhere around more than 80% is the rain volume contributing to surface runoff, while the storage is very less, which is 75 TCM, while the unutilized water is 91. And now if we see here in the winter rainfall is very less, which is 100. And since we all understood in the week 2 that the village is rain dependent, hence the storage has, and that's why the storage, that is lake storage, is also rain dependent, and that is also very less, which is 7. And again the loss of water in the form of surface runoff is very high, which is 80. Here too it is dominating, which is 33 of 50, right? And the storage is almost negligible, which is 1 TCM. So now we can take storage and surface runoff as the two processes from the season-wise water availability in the village, and compare it with the water demand, which is what shown in the next slide, which is this. This is the most important slide because this is what we have been discussing since week 1, and finally we reached a place where we can have a solid comparison of how much is the storage available in the village and how much is the demand, and whether we are able to meet the demand of the village using the storage water. So give some time in understanding this graph. Here, if we start from monsoon, the surface runoff, as we remember, it was 1175 TCM, and that's why it cannot be accorded in the given scale of the graph. But yeah, I have shown here that it's still going. It is 600, but it is 1175 is the surface runoff during monsoon. However, the storage was 465. Now, corresponding to the storage and surface runoff, the agricultural water demand is 245 and non-agricultural water demand is 11 TCM. So it is apparent here that why the farmers were cultivating paddy, which was the water intensive crop, because the water availability is far greater than the water demand for agriculture and non-agricultural water demand. So hence in monsoon there is no problem of water scarcity. But as soon as we go to post-monsoon season, we see here that the water availability is 75 TCM, but the demand is 140 TCM. And it is due to this difference that the farmers were not cultivating during post-monsoon season, and their aspiration was to cultivate onion. So if they want to cultivate onion during post-monsoon season, they need 140 TCM of water. But the matter of fact is, water availability is very less, half of it almost, which is 75 TCM, and that's why farmers were unwilling to cultivate during post-monsoon season or during Rabi season. But one thing is possible, which is if we harvest even 50% of the surface runoff which is being generated during post-monsoon season, the water demand due to agriculture can be fulfilled, and therefore in the village we found that the non-agricultural water demand was fulfilled because of the storage, but they cannot able to fulfill the agricultural water demand. So that's why people were able to drink water, and most of the institutional water demand was also fulfilled. But when it comes to agricultural water demand, they were unable to fulfill using the storage, because the storage is almost half of the water demand for agriculture. But if we want to solve this problem, what we need is to harvest this water, which is 334. Let's go to the next season, which is winter. In winter, again, since they wanted onion to cultivate, the demand is constant, which is 140. But corresponding to that, we do not have storage available in the village, and it is only 7 TCM. While surface runoff is also 80. So here we can see, even if we harvest the surface runoff, still we will not be able to fulfill the winter agricultural water demand. So now we have come up to one of the very solid result, that even harvesting surface runoff during winter will not be sufficient enough. So what can be the solution? The only solution which I see here is to harvest this surface runoff, which is very, very huge, which is 1175. And to harvest this surface runoff, we need to bring some interventions, and we need to use each of the land use in the village to harvest this very high surface runoff. And this surface runoff can be harvested in our lakes as well. So if we are able to harvest this water in the lake as well as in the other land uses, then it is possible that this water can be utilized until winter or until summer. In the summer, we can see here that we do not have storage. Also, there is no demand because of non-availability of the water. And on investigation, we found that farmers never cultivate during summer. That's why we kept the agricultural water demand 0. But we need water to drink, but we need institutions to support. And Surprisingly, here we do not have water to support the institutions as well. So, on investigation, you found that farmers as well as all the local villagers complained that we do not have water to drink during summer. Women communities were enforced to fetch water from distant sources because their source is unavailable, is not able to meet their institutional water demand. So that's why we have seen in general in India that why during summer season most of the women communities are marching far away in the search of water. And this entire graphical representation is sufficient enough to tell us the story about how some of the villages are facing flood kind of situation during monsoon and how the same village is witnessing drought kind of condition during summer, and people are enforced to walk considerable distance to get water. And therefore, let us come to the final recommendations. We have been developing recommendations since week one, but now it's a time to validate whether our recommendations were exactly as per the requirement or as per the conditions. Due to limited agricultural water availability during non-monsoon seasons. If I say non-monsoon seasons specifically, it is post-monsoon and winter. Cropping pattern can be decided through community interaction. Exactly. So I mean to say that since onion requires large amount of water, so can we switch to certain other crops which requires less water, such that with this availability of water we can have some cultivation, we can have some croppings. So this is one understanding. Community-led forestation activities can allow harvesting more surface runoff and checking soil erosion and lake siltation. This is pretty much required. Why? Because if you can prevent lake siltation, we can keep the volume of lake or the potential storage of the lake intact. Also, the community-led forestation can allow us to harvest more surface runoff, which is the need. As you can see here, that we have larger quantity of water in the form of surface runoff, and if we can come up with some propositions such as forest-led forestation activities, then it can allow us to harvest more of such surface runoff and can allow us to divert those stored water in those forests for other activities such as agriculture. Household level rooftop rainwater harvesting can be proposed to enhance storage from built up land use, especially during monsoon season. And yes, this is pretty much required because if we have such structures, then in the monsoon season, each household can have their own storage, that is private storage, and that private storage can really help them to have drinking water during winter and summer season. Because we can see here that how both during winter and summer there is a huge water scarcity for institutions. So if each of the institutions and built up areas are having rooftop rainwater harvesting schemes, then it can allow them to have ample water storage during this winter and summer. Moving ahead, yes, lake desiltation activities can allow increasing storage capacity, can become reliable water source during non-monsoon seasons. Yes, this is the fact, because if we are one thing, not only about this lake, but we need additional lake as well, because this single lake was unable to meet the water requirements. So even if we are desilting this lake to increase the volume capacity, that is not sufficient enough to meet the requirements as we have seen in this graph. So we want additional lake as well, and that lake volume can be decided based on how much is the unmet water demand for agriculture and domestic purposes or non-agricultural purposes. Also, the desiltation allows us to obtain silt, and the silt is actually a fertile source for agricultural soil. So one thing is clear, that with these interventions we can definitely be able to increase water conservation within the village, that can be able to solve water scarcity problems, especially during non-monsoonal seasons and more specifically during summer. So what did we learn from this week 1, 2 and 3 interaction? Week 1 focused on developing narratives on water scarcity issues in the village based on annual water budget. So our focus there was annual water budget. Based on the broad findings from week 1 about possibility of water scarcity, the investigation was narrowed down to seasonal water estimation during week 2, such that we estimated surface runoff, and we found that this surface runoff was observed to be the very high and a possible reason for high water unavailability in the village. This is what we realized during week 2, and that's why we were very confident in week 3 with regards to water availability conditions, and that's why we were interested to find out how much is the demand and whether the availability is able to meet the demand or not. So in week 3 investigation ascertained the water scarcity issues and attributed excess surface runoff as the primary reason behind unmet water demand for agriculture and non-agricultural activities during non-monsoonal seasons. So if I want to become specific, so the agricultural seasons where the water was unmet is the post-monsoon season and winter season, while with regards to non-agricultural water demand, the unmet water for these non-agricultural activities was mostly during winter and summer. So definitely, in general, the non-monsoonal seasons like post-monsoon, winter and summer are the target monsoons where water scarcity issues are persisting, and we have seen how we can increase the water conservation or how we can increase the water availability across these 3 seasons through some interventions that we discussed in the previous slide. So before I end today's discussion, it is imperative now that we can have some broad discussion in week 4. So based on the suggestions that I received in the week 3 interactive session, I have brought some changes because now we have already seen what are the problems in the village, and we quantified the problem. We also identified the demand of the water in the village, and we have seen that how to actually come up with certain solutions which can exactly solve the water scarcity problem across each of the season. So this was a kind of hypothetical problem that we developed, but why not to see some real problems? So we will discuss the real case of Madurai's rural, peri-urban and urban water supply demand issues and the estimation of water budget, right? So for this purpose, for this case study, we will be referring to these 2 papers. So the first paper is on water management using traditional tank cascade system, a case study of semi-arid region of southern India. And another paper is the follow-up paper, which is the revival of traditional cascade tanks for achieving climate resilience in drylands of South India. So the first paper has discussed about water budgeting aspects with regards to how much is the storage available, how much is the surface runoff, how much is evaporation, evapotranspiration, and how much is the precipitation received in each of the rural, peri-urban and urban landforms. And the another paper has discussed about water supply and demand. So how much is the water available for supply and how much is the demand? For example, here in this case study, in our village, we have seen that the demand was from institutions such as Anganwadi or schools, etc. Likewise, in here we will be seeing how the demands were able to get fulfilled or not fulfilled because of the storage facilities available in the village. So I will request that you please spare some time reading both these papers. I will be sharing the links of both these papers in the YouTube channel as well. So once this interaction will be made available on the YouTube, you will be able to access the links as well. Otherwise, you can also search this paper on Google Scholar or simply on Google. I thank you for watching this video, and I would request you to stay tuned for having more such discussions and having some real case study interaction about Madurai rural, peri-urban and urban water supply demand issues. Thank you for your time.